All right, let's do example 105. It says find the kernel of this linear transformation. All right, so again, I'm just going to take this matrix and copy it. I'm going to do that the lazy way. And I even messed that up by including some extra stuff here. So we're going to take that and we're going to augment it with zeros and row reduce it. Let's get rid of this. So row reduce that and see what we get. All right, so 2017 9 0 16 10 11 0 2017 9 0. All right, that looks good. Row reduce that. We get some kind of ugly looking numbers. Let's change that to rational format. Those don't look like they're too bad, but I can't recognize them right off. Yeah, there's no way I would recognize those fractions. So we get 1, 0, 97 over 72. And then 0, 1, negative 19 over 18. And then a row of all zeros. All right, so x, y, z. So if I write this out as a general solution, I get x is equal to negative 97 over 72 z. That second line gives me y equals 19 over 18z. And the last line doesn't give me anything, but z is a free variable. So I get this right here, and I could leave my answer like that as a general solution. If I wanted to, I could also, oh, I'm sorry, I just realized my octave is still up there. So I could leave it like that. If I wanted to, I could come in and, rewrite it like this. But let's look at writing it the way the book does. The book would say that this would be a point of the form minus 97 over 72 z, 19 over 18 z, and z, where z is a real number. Now, those are ugly fractions. And can we get rid of them? Yes, we can. Because remember, this is finding, these are solutions. And we can pick any value we want for z. If we wanted to, we could scale this thing and get something that's nicer. Now, 72 and 18. Let's multiply all these by 72. So if we do that, we're going to get minus 97 z. Let's see, 19 over 18 times 72 is 76. And then this is 72z. So I've got 3 different things in boxes here, and all of them are perfectly good answers to this, because it's finding the kernel of the linear transformation. This right here, it's going to give us the exact same numbers that we would get up here. It's just going to change what the z is, or what the value of z is that corresponds to a solution. But anyway, that's the kernel of this linear transformation. Before we go on, though, let's talk about what this means. The kernel of this thing is that, if you think about it, this is a line. So we've got this linear transformation that takes in vectors from R3. When you multiply it out, it gives you a vector in R3. I guess a better way of writing that is, in this case, T maps R3 to R3. Anything that happens to lie on this line is going to get mapped to the 0. All right, let's look at examples 106. Find the kernel of this linear transformation. So again, we just want to take this. I'm going to be lazy and just do this and row reduce it. So 11, 5, 12, 3, 2, 4, 15, 3, 11. Okay, I forgot to put my zeros in there. Now I'll go back and put them. Okay, now when I row reduce this, notice what I get. I get the 0 vector. Or not the 0 vector, the identity matrix. So what this tells me is I've only got one answer here. X is 0, Y is 0, and Z is 0. So what that means is the kernel of this, the kernel is just the single point 0, 0, 0. That's the only thing that gets mapped to the 0 vector by this linear transformation.